Hi everyone, welcome to the Ravit Show. I'm Ravit Jain, your host for the day. Today on the Ravit Show, I'm joined by David Flynn, founder and CEO of Hammerspace. Long view. Obviously, I've been chatting with Hammerspace team since a long time, and obviously learning all the great things that they've been doing in this space. Today we are discussing about why NVIDIA's AI data platform is the blueprint and why Hammerspace is the engine. So, who better to have David himself to talk about this? We'll get into data power, AI anywhere, and how this changes, for enterprises to build and scale AI. First of all, David, it's your debut. Excited to chat. Welcome on the Ravit Show, and excited to
I'm
discuss about various things. So, thanks for taking the time out and joining us today.
excited to be here. Thanks for having me, Robert. We're
Uh,
super
awesome.
excited.
Yes, David, just for audience, would you like to quickly tell us a little bit about Hammerspace and
Mhm.
what's the mission?
Hammerspace is all about uh, getting rid of data fragmentation, unifying data across systems and across data centers. Because if there's one thing for sure, it's that AI
Right.
is forcing radical changes in how people build and run infrastructure. Um, I like to say it's the forcing function to cause us to clean
Yep.
up a lot of the mess that we have coped with for years, but now we really have to overcome it.
Yeah, love it. Thanks for sharing that. David, I'm going to jump in. Everyone's talking about compute power, but few are actually talking about the data power behind AI. From your perspective, what's changing in how enterprises think about data in this new AI era? Because you talk to a lot of customers, right? So I'm kind of curious to
Yeah.
hear your thoughts.
Well, I think of it about the operationalization. I mean, in the early phases of AI, we're glad to get it up and running. And that's a lot about getting the GPUs and the networking and all of that. But
Right.
for us to truly, reap the benefits of it, we got to feed the thing. Um,
Mm,
and not just on the training side, but on the inference and fine tuning. The
right.
value comes from having it perform an operation on data. I like to
Right.
say that really AI is so revolutionary because it allows us to make sense out of what was unstructured data. Um,
Sure.
and so now the bulk of data, which is unstructured, has utility to it. But for that, we need to be able to retain, house, and feed that data into the systems. So data has and always will be the actual bottleneck at the end of the day. The
Yeah.
compute and the networking, that's all transient. It can come and go, but data is where things need to be permanent. So it puts you on a collision course between making things super reliable, permanent, for safe retention of data, and being able to deliver it very, very fast and agile into these systems.
Yeah, I can't agree more because I talk to a lot of enterprise leaders, and the first thing that they say is, Robert, we can, we can definitely implement AI, but we need to make sure that our data is ready for that. And you
Yeah.
touched points around that itself. So thanks for sharing that. You've also described, and I've been kind of, obviously seeing that Hammerspace as a data platform for the AI anywhere era. So I'm
Yeah.
kind of wanting to know what does that era look like to you, and why is that data now the foundation of AI strategy? So yeah, just curious to hear
So
your thoughts around that.
the way I think of it is complexity arises when you have a cross product problem, when you have a many to
Mm-hmm.
many. And the issue with AI is that um, because of its power consumption, it ends up being something that is geographically distributed. You can only get a certain quotient of GPUs in a given location before you need to go elsewhere. So one of the defining features of the era of the neo clouds, these new clouds,
Mm-hmm.
is that they are more granular and more distributed. With the
Right.
legacy clouds, I mean, you had US East and you had US West, and these are like big, massive things. But with GPU clouds, you're going to have to shop for the correct venue to find
Right.
the gear. And because you invariably run out of power budget in any given location, it ends up being physically distributed. Um, and
Mm.
if for no other reason than just to be able to afford it by being able to arbitrage and go to where you can get GPUs that are inexpensive. So, on the one hand, we have this issue of things that are being physically distributed across geography due to the fact that it has to be
Right.
tethered to the power grid, and it's the real world of having to feed the thing. And on the other hand, you have the data sources. You have data coming from a myriad of different applications that
Yes.
exist themselves potentially running out of different infrastructure locations, but definitely out of potentially different systems. And in the past, we've had a very simple relationship. You run an application and you put its
Mm-hmm.
data into storage. And you have a one-to-one relationship between an application, its data, and the
Yes.
storage that stores it. You might coincidentally use the same storage for another application, but that's just a coincidental thing. Now, all of a sudden, we have
True.
this issue where we need to gather the data from all of these different systems, and we need to make it available to the AI systems, which are themselves. That's why I mean cross product, because now you have many different systems and
Mm.
potentially different locations. And so um, the the breaking point that we're being forced to address is the manual staging of data. Because
Mm.
here's the third dimension to the problem. This isn't a just a one-off. It's not just about getting this data over here at one point in time. It's about needing a continuous flow. These are about workflows of data. So when we talk about AI anywhere, it really is revolutionary to be able to uh, decouple data from the systems where they are stored and
Yep.
orchestrate the data behind a single namespace and a global namespace so that you have singular unified access to data, which can now programmatically move freely to be in position in the right place. And the key to all of this is taking the human out of the loop.
Yep.
You don't need a data janitor. You don't need data migrations. You can't afford any of that. It doesn't work at the right time frame. In a way, you
Mm-hmm.
could say this is about being able to apply AI to be able to drive the workflow itself, which is running AI. With Hammerspace, we make it possible to automate the movement of data across systems and across data centers and putting it behind a single unified pane of glass where it's continuously accessible. There is no downtime required. If you access a data object that's not yet there, it will go and fetch it on demand and do it immediately. So this
Mm.
allows us to automate the stuff that used to be manual, take the human out of the loop.
Yep.
And by doing that, you can set it free to run continuously and to run at in a tighter iteration loop and get more value from it. So this is, really more than just the AI anywhere. It's about being continuous, always on, and not requiring manual data staging. See, today we end up having to stage data from one storage
Mm-hmm.
system because it's very good at long-term retention and we trust it to protect our data. We end up having to stage it into these temporary systems that are high performance and
Mm-hmm.
geo. So all of that ultimately has to go. We have to get to a world where we can automate the things. And the funny thing is, the industry, this reckoning has been coming for eons because cloud
Mm-hmm.
computing
Yep.
itself has has wanted this ability to run anything anywhere without having to worry about where the data is. Hybrid cloud, multi-cloud, multi-regions within the cloud, or just multi-data center operations. We've needed that for a while, but with AI and this limits to power budgets and the fact that we need to have data from many different systems is really
Right.
forcing us to overcome the geographic uh, uh, distributed nature of
Just
data and automate the orchestration and presentation of data, um, so that you're not working at the speed of us mere humans.
That's so true, and this is well explained. Thanks for sharing this in detail, David. Very much helps us understand. It's not only just about the AI anywhere era, but also about not having the human in the loop for these manual tasks that which were happening earlier. I have a follow-up question to this. Do you also see this as the beginning of a broader shift from building AI around compute to building AI around data as well? Because this is a topic I always
Yeah,
love
yeah,
to
yeah. No,
catch
you've
up
hit the
on.
nail on the head. It's, data centric. It's
Yeah,
almost like object oriented program where you
right.
focus on the noun, not the verbs, right?
Mm,
Because AI is so new, we've been focusing on the verbs, the actions. But in reality,
exactly.
it starts with and is centered around the data itself. And so a data centric computing is absolutely, the direction we need to go. And having single logically unified global namespace, global data space,
Right.
and having automated orchestration so that the data can actually be not accessed at a distance, but accessed. So this is kind of a paradox. How can you have data everywhere that you need it without
Mm,
ever having copied it, and without
yep.
ever having to wait, and yet have it local? And the answer is through orchestration. You can have
Mm,
continuous access to data while it moves, and the data can move to be co-resident in the right data center, even on the exact same system that needs
exactly.
it. But it's not a copy when that movement of data doesn't change what the data logically is. That's why we have to have a logically unified um, namespace
Right.
that everything accesses through, and yet have the data be able to live physically distributed and movable. So yeah, the cloud is what got us started, but cloud only needed two dimensions. It needed the agility of uh, movement of data and the cheap and deep capacity. Um,
Right.
but but AI adds a third dimension, and that's needing high performance. So now it's not just
Mm,
that you need a lot of capacity, it's that it needs to be delivered with high performance, and it needs to be delivered with agility across systems, potentially in different geographies. And
yeah.
so we could cope. We could cope with two of those dimensions: cheap, deep capacity, and maybe
Right.
moving it between different data centers. Although that was very cumbersome and manual to take the data migrations to move it around. Now,
So true.
uh, now it has to be automated, the movement of data, and it has to be delivered at high performance.
Yeah, and I know for a fact where David, you've very much also aligned with closely with NVIDIA around this, and also built an AI data
Mhm.
platform solution. How do you see this partnership accelerating productivity of enterprise agentic AI? I'm also wanting to learn a little bit
Yeah.
about that if you can share.
Well, this again goes to early stages versus the operationalization. We're getting
Right.
to that operationalization where if
Mm-hmm.
AI is going to live up to its hype and not just be hype, and I sincerely believe that it's not just hype, but to get
Mm-hmm.
there, we have to operationalize it and you have to be able to extract value from it. And,
Right.
it's one thing for AI to exist, for this, machine intelligence in a machine to exist. It's something else for it to bring us value. And for that,
Mm-hmm.
we have to give it data. And that requires all of the logistics and of the high performance retention,
Right.
orchestration of data around. So this AI data platform, you can think of it as branching out to now where we are talking about the concerns of how to operationalize it. It's a platform. It's not just a novelty that you can ask, questions and feed text. It's, because another dimension to this is we're rapidly moving to where it's rich media and visual and audio and images of all types that it can interpret, whether that's CAT scans and MRIs and medical scans, or
Right.
manufacturing process steps, or the types of images for building microchips. This takes us into a higher dimension and a much larger volume of data than just
Totally.
text. So, now that we have the ability for machines to use language and logic, now applying that to visual imaging, seismic data of oil fields, or the images of the circuits that you print on microchips. All of these things are going to be revolutionized through AI, not just the medical
Right.
fields, but even proteins and protein folding. At the end of the day, this is highly dimensional data, three-dimensional data, two-dimensional data, and it's massive.
Yep.
So I see this as basically now we can gain value from having machines that can perceive what used to be they couldn't. It used to require a human to understand
Yeah.
that. So now we just need to build the platform that can do that. And you want to hear an interesting thing, and
Yeah,
that
for sure.
is that with Hammerspace, you can actually use the AI tools to control how and where the data is moved in an environment. So this is about allowing AI to be self-optimizing in the sense that it can use uh, the uh, uh, orchestration, the
Mm-hmm.
service level objectives and orchestration capability of Hammerspace as a platform, to pre-stage and to put data into the right data center, onto the right systems where it's needed. So this is about not only taking a human out of the loop, but allowing for intelligent machines to be able to command the placement and movement of data in support of the inference or training, or other activities that are going on. So it's not just that we're overdue for
Yeah.
automating the data janitorial work and the data staging and such. It's that as soon as we can automate it, then we can empower AI systems to uh, fetch the things which they need
Yeah.
um, in the first place and get it into the right places for use.
Yeah. David, this is to the point, so interesting and such insightful points that you're mentioning. I can talk to you for hours for sure. But looking ahead in 2026 and beyond, what's the next major AI barrier in infrastructure that you feel that we as an industry has to overcome, and how does Hammerspace plan to
Mhm.
lead that charge? I'm kind of
Mhm.
curious to know a little bit about the future as well.
Well, we see the Hammerspace AI data platform as fundamentally pushing the frontier of what's possible on
Mm-hmm.
the three most important dimensions when it comes to data. We've been talking mostly about the first, which I believe is the most important, and that's automating the ability to move data and present data universally. So that's our single global namespace with data orchestration and being able to do that on top of existing storage systems. So think of it as the
Right.
virtualization or abstraction layer, and it's the ability then to automate and take a human out of the loop. You don't need to take downtime. You don't need to reconfigure applications. So now you can
Right.
start automating a bunch of stuff. That, I believe, is the single most important dimension and the thing that has been least developed in the industry. We virtualized compute We virtualize networking. We've never virtualized data from the underlying storage. That's absolutely necessary for us to automate that stuff. That's dimension number one. And incorporating data-centric compute is the future there, to where the mere existence of data in the unified namespace causes certain processing to occur. We have the notion of job schedulers for batch scheduling. We have orchestrators, microservice orchestrators for continuous services. But what we really need is a data-centric computing model where things revolve around the presence of data and just the arrival of data. Think of it like Lambda functions, but on steroids, right? So we're going to see pushing the envelope in terms of agility by having a data-centric compute in this AI data platform. The other two dimensions are similarly challenging, and where our architecture allows us a unique advantage to push the state of the art to unprecedented new levels. And the next is the performance. Hammerspace being able to aggregate physically distributed systems into one unified and get the full throttle performance from all of those, we take to the extreme of being able to use the local NVMe inside of the GPU servers themselves as the scaled out high performance. This is not hyper-converged storage. This is a new tier of storage among many, because the environment's orchestrated. So it's called tier 0. Tier 0 advances the notion of high performance file well beyond even what was done in the supercomputing world, things like the Lustre file system or Weka or GPFS. This actually promotes the data to be co-resident on the same node and with direct local access performance. It allows us to incorporate what is otherwise the caching tier as actually part of the shared storage space. And that is only possible because we're using standards-based protocols that are native to Linux. Our data path is Linux. So that allows us, and we've enhanced Linux to be able to recognize when it's serving itself and get that direct local performance. So this second dimension around scalable performance is being brought to crazy extreme new levels through incorporation of tier 0. And I'll mention that has major benefits to the cloud because clouds have notoriously poor networking. It's inherent in the fact that clouds are very big, and therefore the networks end up being very deep and slow. But with tier 0, the data can be promoted to live on the near side of the network, in the compute nodes, among the compute nodes, or inside the very compute node. And therefore you can bypass needing to go across the north-south network, and now it's just east-west between the GPU servers. So having a standards-based parallel file system at the heart of it, Hammerspace allows for the creation of this new architecture of tier 0, redefining performance and cost performance. And that's all about utilization of GPUs, minimizing the time it takes to ingest, to write out the data, and to do checkpoints, et cetera. This is about bringing utilization of the GPUs up into the 98% utilization, because you never have to wait on the data to arrive. And then the third dimension is the cost of retaining data over time. And this is where our work with the Open Flash Platform Initiative and being able to build high capacity storage systems that don't need dedicated storage networks, don't need dedicated controller nodes, and can be built with nothing but a NIC and NVMe. Disintermediating the storage servers and the dedicated storage networking and block protocols altogether, having data originate from the storage node as file storage so that you don't need another thing to add the file system. That has the ability to eliminate 2/3 of the TCO. It gets rid of 30% of the upfront CapEx, 90% of the ongoing OpEx,
Wow.
because it reduces 90% of the power. Most of the power in a storage subsystem is that storage network and the
Right.
controller servers that add the file system and everything. And by getting rid of all of that, you're basically getting rid of 90% of the power consumption. So 90% reduction in OpEx, 30% reduction in CapEx, and extend the lifetime. Because one of the other reasons that the storage subsystem lasts a mere 5 years is because the storage networking and storage servers and all of the trappings around the flash devices themselves. I know this. I built the company Fusion.io. We pioneered the modern flash device, and those have no problem living 8+ years. But the problem is you end up having to throw the baby out with the bathwater, because the servers and dedicated storage networking that it takes to build that into shared file storage has a limited lifetime. And so you end up throwing out the flash because of those servers. With the open flash platform and the fact that all you need is a network adapter, and you can originate the data on the network as file storage directly and not have to go through a dedicated storage network and controllers, completely changes the game. It means that for the same dollar, you can buy 3 times as many petabyte years of data retention. And that's a game changer. And it can be visualized by the fact that we can fit in a single one-use slot what today takes an entire rack of gear to do.
Right.
Yeah. If you will, I'll grab something here to.
Yeah, for sure.
Just a show and tell. One thing. This is one of the OFP sleds. This baby will be 4 petabytes here in Q1. 4 petabytes in a sled, and you can fit 5 in a regular rack, or 6. So you're talking about 20 to 24 petabytes in a single rack U of space. Each one of these sleds has 800 gigabit networking. So it really is collapsing an entire rack worth of storage infrastructure with the legacy architecture, like a VAST or a Pure or a NetApp or those guys. It collapses it down to where in just one rack U or 2, you've got the equivalent.
Exactly.
It's literally an exabyte of capacity in a single rack. So that's the future, is redefinition of the capacity tier, redefinition of what performance tier is, and redefinition of agility.
Love it.
Yeah.
Yeah, I think, David, this is extraordinary, and thanks for giving us a quick show and tell as well. It looks very sleek and very powerful for sure. One last question that I have for you is about, first of all, thanks for sharing all the great insights that you did today. I really appreciate it. But one last question that I have for you is, if people want to learn more about the different things that Hammerspace is building, which is the best place to go and check out? And if they want to follow you, where can they do that?
Yeah. Hammerspace.com, and you can follow us on LinkedIn, X, Facebook.
Nice.
Either me and or the company. But Hammerspace.com, come and look us up. Have information going up there about the new announcement with NVIDIA and the AI data platform.
Yes.
So, love to hear from
Can't
you.
wait.
Reach out to us.
Yeah, can't wait. Thanks for once again visiting the Ravit Show. You shared some amazing insights, and definitely looking forward to sharing all the content with our audience as well. And we'll share some links with them to have a look at, obviously the partnership that you all have with NVIDIA, but otherwise as well about the AI data platform and other content that you all continuously push ahead to make sure that the community, the enterprise leaders are always learning. So appreciate it, and David, we'll keep the conversation going. Can't wait to meet you in person and also do a 2.0 version.
Can't wait for a follow-up. We'll do it again.
For
Thanks,
sure.
Robert.
For sure. Thank you very much, David. Thanks everyone for joining us today. Stay tuned.